As a developer, my primary focus is on the code and bringing value. In this clip, we will see how everything we have discussed so far comes into play to let me focus on making changes to the code and leaving the automation do the rest. We will be working, as mentioned earlier in this series, in a multi-cluster environment. 2 x86 clusters, named Onyx and Topaz, an IBM Power cluster, named Opal, and an IBM Z cluster named Diamond. The end goal is to have an application distributed on all the different clusters. We will be using Onyx, an x86 cluster, as a development cluster. I like to call it a master cluster or a control tower. This is where the development process as well as the automated pipelines are going to run, while the rest of the clusters will be workload clusters, used for building images remotely as well as running the services in testing and production environments. The workload clusters are managed by the control tower using Red Hat Advanced Cluster Management and can communicate with each other via the Submariner add-on. Using the Cloud Native Toolkit, we have a set of DevSecOps pipelines ready to use for multi-architecture builds. There is a bit of setup that has been done earlier by a cluster administrator. You can find the Terraform script to automate this setup in the resources section. At this point, as a developer, I only need to push the new code. Then a set of automated tasks will be triggered, from testing to building to deploying the code. Let's create a pipeline for one of our services. Now, before I start the process, I'm going to create the GitOps repository that will serve later on for deploying the code. Using the igc gitops command, followed by the address of my repository, I tell my pipelines to use this repository as a GitOps repository and push code configuration changes to it. The repository is empty for now, but we will see the change at the end of the pipeline. Great! Here I have the codebase for one of my services. It's a mock payment service written in Node.js. Using the igc command line tool, I can create a pipeline for this service. After filling in some configurations, the pipeline will start running. Here we go through various steps. A setup step that creates a bunch of variables that will be used by the pipeline. A code lint step that runs a set of checks on the codebase to see if there are any issues. A Dockerfile lint step that verifies the Dockerfile to see if it follows the best practices. Then we give a version to our code following the semantic version in standard. At this point, we build remotely our images. We are using the workload clusters as agents that will build the images. Remember that images are architecture dependent, so we need to build images on physical platforms. After the image is built, we push it to the image registry, which will be query.io in my case. The next step after building multi-architecture images is, you guessed it, creating a manifest file. This file will act as a pointer to specific architectures and will be used by the workload clusters later on to run the images. The tricky part is over now. we deploy the application on the development cluster and perform a health check on it to make sure it's up and running. This is useful in a context where the code is doing fine, but the container itself has problems starting up. Could be a network issue, for instance. After that, we scan the image using Trivy and give it a new tag to release it afterwards as a Helm chart that will be stored in Artifactory. The final step in the pipeline is to update the GitOps repo and give our application a new version that will be picked up automatically by Argo CD. What we have achieved so far is the CI. Now on to the CD part. Using Argo CD, we create an application. This is a way of telling it to target a given GitOps repository and deploy whatever configuration there is on it. For my payment service, I will target the GitOps repo that I've created earlier and give it the exact location of my code configuration. In my case, this is the Helm chart link in Artifactory and its version to be deployed. After creating the application, Argo CD will pick up automatically this configuration change. We should have our application deployed afterwards. And that was all for this clip. I have showed you how to deploy one service using OpenShift pipelines, OpenShift GitOps, and the Cloud Native toolkits. We will be doing the same steps for the rest of the microservices. Needless to say that when a change occurs on one service's codebase, its corresponding pipeline will be triggered and all the steps that I've mentioned and explained in this clip are going to run automatically, ensuring a seamless transition between the old version and the new version.